Hey geometry class, we are going to be looking at section 7.1 and this is the beginning of our chapter on trigonometry. This is going to be, just be a quick chapter about all sorts of things that we actually do begin learning in trigonometry. And to start us out, we're going to be looking at the Pythagorean theorem. I know this is probably something y'all have done before. We've actually used it in class before, but let's just get us started with using the Pythagorean theorem. So yeah, let's go get started. Okay, so here's the theorem right here. And Pythagorean theorem can only be used on right triangles. And here's how it goes. So in a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the square of the lengths of the legs. So right here, um, our side that has A and then our side that has B, those are called the legs of our right triangle. And then the side that is the longest on our triangle, or that is opposite of our 90-degree angle, this is always known as our hypotenuse. Okay, so let's go ahead and take a look at using these in an example. Okay, it says find the length of the hypotenuse of the right triangle in these examples. So you're already told that this length that is missing is the hypotenuse. This is going to be our value of C in our a squared plus b squared equals c squared formula. And then it doesn't matter which you label A and which you label B on your for your legs of your triangle, your right triangle, because uh, you're going to be squaring them both and adding them together. So it doesn't matter which one you actually choose. I'm just going to say this is my A and this is my B. And now we're going to plug it in. I'm going to write it a little bit differently. I'm going to write c squared equals a squared plus b squared. And now plug in everything. This right here is my x that I'm looking for. And then this is 45. Square that. And 24. Square that. When I square those and add them together, I get, don't forget your square, 2,650. Now on this thing it says write your answers in simple radical form. What that means is I'm going to take the square root of both sides of my equation here to get x equals this right here, whoops, the square root of 2,650, that number on the inside of the radical can break down into two factors, and one of the factors you can take the square root of. So I know that 25 is a factor of this, and 25 you can take the square root of. And then the other factor is 106. All right, so 25 is the highest factor of 2,650 that you can take the square root of. There's no other number inside this number right here that is a factor that you can actually take the square root of. So that is why I chose 25. Now, you split this radical apart, take the square root of 25 times the square root of 106. Well, square root of 25 is 5 times the square root of 106. And this is what it means by simplest radical form. You're not going to be simply plugging this into your calculator and giving me a decimal answer. This is the answer I am looking for right there. Okay, so let's go ahead and do it again. Again, this is opposite of the 90-degree angle. It is my hypotenuse, my value of C. I'm going to label these my A and my B's and plug everything in. So C squared, which is X, equals A squared plus B squared. And now square these values, add them together, and you get 325. Taking the square root of both sides of this equation to get x all by itself, I get this value here. Again, 25 is a factor of 325. and that splits into 25 and 13. 13 is a prime number. It definitely does not have any other factors that you can take the square root of. So square root of 25 is 5. Square root of 13 is just that, square root of 13. So this is my value for x. Now this one asks us to find the unknown leg length x. So we have the value of c. This is our hypotenuse right here. And this is, you can label it either a or b. I'm going to label it a. This is my b. Plug it into your function. A squared plus b squared equals c squared. So a squared, well, which is x, plus b squared, which is 18, equals c squared, 25 squared. Now solve for x. So square these numbers, subtract 18 squared from both sides of the equation, and you get, I'm just going to go ahead and write it out, that there. And 25 squared minus 18 squared is 301. Take the square root of both sides of the equation, and you get x is equal to the square root of 301. 301 does not reduce at all. Okay, let's go on to the next one. So this, I'm going to again call it my A. This is my B because this right here is my hypotenuse, which is C in our formula. So A squared plus B squared equals C squared. Okay, now again, do the math. Get x squared by itself. And then again, calculate this value right here. And I get this right here, 468. Take the square root of both sides of your equation, and you get x is equal to the square root of 468. 468, the factors of that can be broken down into 36 and 13. You can take the square root of 36, so go ahead and do that. It's 6. And then what's left over inside the radical stays inside the radical. So 6 square root of 13. These right here are the common Pythagorean triples, and then some of their multiples. See how we have, this is a Pythagorean triple. Well, this is the same thing, just everything's being multiplied by 2. Everything's being multiplied by 3 from the original one. So here's 4 of the common Pythagorean triples, and then some of their multiples. And what makes a Pythagorean triple is that all 3 numbers will be one of your sides in your right triangle, and then all of them have to be whole numbers for it to be a true Pythagorean triple. So it's a set of 3 positive integers, a, b, and c, that satisfy this equation right here. In these examples, we're supposed to find the unknown side length, just like we've been doing, but then we're going to tell whether the side lengths form a Pythagorean triple. Okay, so this one right here, this right here is our hypotenuse, so that's our C in our formula. I'm going to name this our A, and this is our B. Now saying A squared plus B squared equals C squared. Solve for x. So we're going to say 13 squared minus 12 squared. That there gives us x squared equals 25. And that there gives us, when you take the square root of both sides, we get 5. So that is our unknown side length, 5. And since all three of these values right here, 13, 12, and 5, are integer numbers, and this is a right triangle, this right here is a Pythagorean triple. All three of these values, 5, 12, 13. Now let's do it again. This is our hypotenuse, so our C. I'm going to name this our A, and this is our B. So A squared plus B squared equals C squared. And then this here gives me 61 x squared. Well, 61 equals x squared. Take the square root of both sides. We get x equals square root 61. 61 is a prime number, so we cannot take the square root of it, or there's no factors we can actually take the square root of. So that is our answer right here. Since this value is not an integer value, square root of 61 is some long decimal number, uh, these three values, 6, 5, and square root of 61, is not a Pythagorean triple. The last example I have for you before we go on to the lesson quiz is we're going to find the area of the isosceles triangle. We're going to write the answer in simplest radical form again, and we're going to be using our Pythagorean theorem to help us in figuring out the height or the altitude of this triangle. So this right here is going to be one of our legs in this triangle. I'm going to highlight it in this triangle right here, which is a right triangle. This is one of our legs. I'm going to call it my A. And now my B is going to be half of this. Since this is an isosceles triangle, then the altitude is going to split the base here in half. So this is C. Oh, B, sorry. And this last value is our C. Now, using that, we can get our height. So A squared, or H squared, plus B squared equals C squared. Subtracting 7 squared from both sides and evaluating that, we get 51. H is the square root of 51. And again, that can't be reduced any more than this right here. So now that we have the height, find the area. Using area of a triangle is 1/2 base times height. So area is going to equal 1/2. Our whole base of this triangle is 14. And our height was the square root of 51. Evaluate that, we get, and if we are leaving it in simplest radical form, like the directions state, 1/2 times 14, that gives us 7, times the square root of 51. That is the simplest form we can leave our area in. And the units of measurement for area is going to be inches squared, or square inches. And that is it. Now this right here is what I'm calling our lesson quiz for this lesson. You find out what this length is equal to by using your Pythagorean theorem. So just to get you started, remember the hypotenuse in your Pythagorean theorem is going to be opposite of the right angle. So to get you started, figure out what this value is equal to. Let's call this B and this R C. So find what A is equal to. And then once you find A, search for, again, what this value is equal to. You can call it some other letter. You can call it C if you want to. Now find C. Once you find C, that's a leg of this triangle. And then this is your other leg. You have two sides of your right triangle here. Find what X is equal to. So that is all I have for you, and I will see you all in class. Goodbye, everybody.